Hello everyone, my name is Shikha Jain and in this tutorial of data structures we are coming up with lecture 2. So in this particular lecture we will talk about address calculation in linear array and 2D array. We will talk about time space trade-off and other concepts of data structures. So first of all we'll talk about array and address calculation in array. 1D. We are talking about 1D first, then we will talk about 2D. So all of you already know that a linear array is a list of finite number of homogeneous data elements, and the elements of array are referenced respectively by the index set consisting of the consecutive number. So if we have array like we have 0 index, first index, second index and third index, so the size of the array would be upper bound minus lower bound plus 1, that is called as upper bound minus lower bound plus 1, that is called as the size of the array. So the size of this array is 4. It means 4 elements are stored in this particular array, and we know that upper bound is this quantity and lower bound is this quantity. This is the size of the array. So we can declare as a of 10. Let's suppose I am declaring int a of 10. That means 10 is the size of the array and the indexing will go from 0 to 9. So 0 to 9 are indexes, whereas 10 is the size of the array. So when we are talking about the address calculation, so how we will calculate a linear array address? So as we all know that if it is integer elements, so 2 bytes storage space would be required by each cell. So if this address is 2004, so the next address would be 2006, next address would be 2008, because in arrays elements are stored at consecutive memory locations. So in array elements are stored in consecutive memory locations, and in consecutive memory allocation we can easily calculate the address. So location of any element k in the linear array LA, so we need to find out the address location of kth element in LA array. So this is equivalent to base of LA, that is base address of LA. So if I'm talking about this array, particular array, so the base address would be 2004, because the first element address is called as a base LA, and W in bracket k minus LB. So W is nothing but the number of words per memory cell. Number of words per memory cell. So W is called as number of words per memory cell, and K is the index for which we need to find out the address, and LB is the lower bound. What is the lower bound of that particular array? What is the address of the lower bound? That is called as LB. So W is the number of words per memory cell. It depends on the character data, integer type data, float data, or whatever type of data we are storing in a linear array. So let's take an example how to calculate address. So the example is, if we have a linear array LA, and the name of linear array is A, and the lower bound is 5 and the upper bound is 50. Lower bound is 5 and upper bound is 50. And base address is 300. We have base address is equal to 300, and number of words per memory cell is equivalent to 4. Number of words per memory cell is equivalent to 4, and we need to find out the 15th element address. We need to find out the address of 15th element. So how we will calculate the address of A of 15th? Address of A of 15 is nothing but base address plus W. K is 15 minus में LB. So that is equivalent to base address is 300 plus 4, 15 minus lower bound is 5. We can easily say here that the lower bound is 5 and the upper bound is 50. So in this case the address would be 4 into 10. The address would be 340. This is how we will calculate addresses in linear array. Now we will talk about address calculation in 2D array. Now we will talk about address calculation in 2D array. So how we will calculate address in 2D array? So basically in 2D array, let's suppose I have a 2D array just like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 3 into my 3 by 3 array. This is the 2D array and this is 3 by 3 array. So in this case, I can store the elements just like 1, 2, 3, 4, 5, 6, 7, 8, 9. I can store like this because everything is in linear form, not in any 2D form in memory, computer memory. There is no 2D type of thing. And I can store like 1, 4, 7, 2, 5, 8, 3, 6, 9. So these are two methodology to store a 2D array. This is the two methodology to store any 2D array. So this is called as row major implementation. This is called as row major implementation, and this is called as column major implementation. This is called as row major implementation and this is called as column major implementation. In row major implementation, first row is stored first, then second row is stored, then third row is stored. And in column major, first column is stored, then second column is stored, then third column is stored. So this is the row major and column major. So in row major, the formula to store